now live streaming on the Twitch channel,
Yes.
which one day somebody's going to build like a Twitch replacement on Lightning, and I'm going to have to finally set up a Lightning node. But that's not
To get
today.
those that stream of sats
Right, yeah.
sent your way.
Streaming video to get stats streamed in.
That's
But we'll see.
that's a
We'll see.
stream of amazing ideas.
Streaming 2.0. But
Oh
for
yeah.
today, we are just we're talking about programming Bitcoin in Rust.
Yes, we are.
And talk to me a little bit about what we've done and what we're going through. What is this book on the screen here?
So this is Programming Bitcoin by Jimmy Song, and it goes through the steps of building a library, a Python library for uh, like basically a Python wallet for Bitcoin where you can sign transactions, create wallets,
Right.
and we're kind of in the beginning still, but it's getting more and more interesting as we go.
Yeah, let's see how many chapters are there? I mean, we are at the end of chapter 3, and there's a lot of chapters. So we got some time to go. 14 chapters, 9 more or 9, not 9, 11 more chapters to go after this. But we're cruising along.
You did the modulo the other way around.
Right. Right. Modular arithmetic. We've done a modular arithmetic. We've done finite fields, which uses modular arithmetic for their addition and subtraction, all the arithmetic operations. And then we did some elliptic curves using finite fields. And then we are now at the point we are going to be getting to Bitcoin finally, like the first concrete Bitcoin thing. Bitcoin's built on all this tech and all this math, but we are now at the point where we are defining the elliptic curve for Bitcoin, which has a very, very specific A and B value. Which, do you remember what the A and B is for the Bitcoin curve?
Yes, it is 7 and 0.
Well, 0 and A,
Oh,
0, B, 7.
0 and 7. Yeah.
Yeah.
Mm-hmm.
And then
Yeah.
go ahead.
Just look at that. I
Yeah.
just got it the other way around.
Well, and then it also goes into the prime number used in the finite field, and this is an interesting one, this p value, and they've got a little side tangent here where it talks about like how big 2 to the 256th power is. It's just enormous. Like, go check it out if you're that interested. But it's a massive number, and that's the prime number that we are using for our order. And then we talk about the identity point, of the group, because you'll start at the identity point, and what was it? Is it scalar multiplication that you do until you reach the infinity point? And then that defines like your group or whatever, which I think.
Yeah. I think, yeah, one concept that kind of was brought up in this, yeah, like
Generator point.
the third bullet point, the generator point,
Yeah.
which is interesting. We hadn't talked much about the generator point.
What is it?
So the generator point is a point that you add to itself continuously in a scalar multiplication way until you reach the infinity point. And once you reach the infinity point, that's when you found the order of your cyclic group.
Right. And then that we have that defined here as well, the order of that, which is n.
Mm-hmm.
And then these numbers down here, so the 0x prefix just means it's in hexadecimal. Have you dealt with hexadecimal before? Have you?
Not much. No, I started doing this specifically.
Okay, so hexadecimal. We'll go over that just briefly. Hexadecimal
Mhm.
is base 16. Our normal
Oh,
number.
okay. I'm familiar with hex in general, but yeah,
Oh, okay. All
I
right,
see
we're
what
good.
you mean.
We're
Yeah,
good. Okay, yeah,
but
yeah.
I've never like played around with them in coding.
Yeah, no, I've never. I mean, I've never dealt with hexing. I mean, I guess no, I have dealt with hex encoding at some point in the past. Um, but we have all these constants now that we can that Bitcoin is built on, um, and so we're going to define these, and we can define these as constants. Um, and this is sort of like a test that will because what is it? Y squared equals x to the third plus 7 for the Bitcoin curve. So we'll go ahead and write this test as well. Um,
Hmm.
and I think what we might do is we might define a new file for this, and we'll use the SCCP 256k1.rs to define this. And we can take our tests. I can never remember.
Or your tests, if you were from New Zealand.
I
I think
don't
that's
I
how
don't know
you
anything
say it.
about that.
Tests. Yeah, the E's become like different different vowel. Oh,
Really?
watch this YouTube channel. Yeah,
Okay. Okay.
shout out to Viva La Dirt League. It's like this super funny YouTube channel, and they're from New Zealand. So they have
Okay.
a beautiful, yeah, English, New Zealander English accent.
Right. I've yeah, I worked with some New Zealanders once upon a time,
No,
but never.
they never said tist.
No,
And I'm wrong.
not that I remember. Not that I
They
remember.
don't talk like that at all, and I'm just tripping here.
I know. I mean, I believe you. I don't know. That's like the whole other side of the world from where we're at.
Yeah.
So let's.
Oh, and by the way, can you send me the live share link?
Oh yes, yes, yes,
Thank
yes.
you.
I always forget that. Sorry.
Or-
And I'll send that in the Discord.
Sounds
Also,
good.
I liked your use of the verb keated. Um,
Oh
instead of
yeah.
letting me know you were on the Keat chat or in the video call on Keat.io, you said I'm keated, and I don't know, that tickled me a little bit. I liked it.
That's how these things become verbs, right?
Yeah.
Who was the first person that said I'm gonna Google something?
Oh yeah. Well, and then when I was working at Microsoft, this one guy used to call it as this Indian guy, he would call it bingling, like like bing it, right? Or like he wouldn't say bingle it. He'd be like, go check the bingle in search engine, and he had all sorts of like just quirky little sayings, and he was just such a wonderful, very intelligent man. But that was the one thing I distinctly remember was like he would say like, go bingle it. Um, all right, let's
That didn't
man.
catch on.
No, I don't think it did.
Not very much.
No.
It's okay.
So let's sort of man, okay. So we got to figure out how to define these hex numbers in Rust because that's something I've yet to do.
Cool.
But we can define our generator point. It might just be that you just type it in exactly like in Python. So we'll try that first and see if it yells at us. And then we'll go bingle it if we don't understand, if it doesn't work. We're not getting types here, so maybe either it doesn't like it or Service stop. Click to start. Okay. I think our Rust Analyzer server wasn't up and running. Okay, yeah, now it's running. And then we need to do P. P is a huge number. Oh, what was... Yeah, why is this not like getting any code completion either?
Maybe because I hadn't trusted the workspace yet. I don't know if it's gonna make a difference for you.
Oh, okay.
You wouldn't.
It's okay. We were not we had not added it as a mod. Yeah, okay. So now Rust Analyzer is yelling at us. So perfect.
Oh, okay.
Integer literal is too large. Interesting. So hopefully a 64 will fit. Oh, no, let's try unsigned 32. It should fit an unsigned 32, I think. Based on... Thank you. Nope.
Yeah.
Integer littler is too... So maybe we need a 64? It's still too big. All right, so... interesting. Integer literal is too large. And there might be a different way of defining this. Let's do some bingling though. And that is how you define it. Well, let's check that.
Long.
What's that?
Unsigned long.
No, yeah, I think this is
That's
talking. This is a different language. This is not Rust.
Oh, okay.
I don't think. Yeah, this is in C. But let's quickly look up Rust, like defining hexadecimal literal. I mean, it's probably, yeah, it's just defining it with this. Man, so...
Because these numbers are basically 256 bits large, right? Or long.
Yeah.
Like their sizes are 256 bits. So they wouldn't fit in a 64.
Right. No, that's a good point.
Size wouldn't do it.
No, because I think that's going to depend on like architecture. Man. Okay, so let's... This is our first super technical challenge. Big int. An unsigned modulo 256. So do we get then... Interesting. What was... Okay. Was there an entire library that just does modular arithmetic for us on big-ass integers that we could have just been using from the get-go? Okay. Well, that's interesting. 256. Big int. Interesting. So we might have to use this crate then. Yeah, let's look that up. Let's Rust big int. Num underscore big int. I always like to go and look at like the repository on GitHub to see how many stars it has. So, and they might create. I wonder if crates.io has something. That this also might have something that's that gives you usages. See, this one is talking about, okay, big int is telling you to use uint instead. Let's do all-time downloads. Okay, so num big int is looking probably like. So, but I'm also curious what the difference. What is crypto big int? Because that sounds somewhat applicable.
Yeah, for cryptography.
Right.
It has been updated 10 days ago.
Yeah, that was another thing I was kind of looking at. I mean, I don't know. Yeah, updated recency it's hit or miss. Like, you know, this one is updated a year ago, but maybe just because it's like whoever is maintaining it felt it was done. It's good observation though. What is this one? Let's see. Pure Rust implementation.
From the ground up for use in cryptographic applications. That seems pretty.
Yeah, because a lot of when it says pure Rust, it's because a lot of them will have what they call like C bindings, and so they'll like it's like a mixture. So I'm pretty sure that's what it means when it talks about pure Rust. Okay, well, I mean, I guess we could try this one.
Yeah.
Big internet library ground up to use crypto applications. I wonder which dependents, what crates are using this. Okay, so there's an elliptic curve crate that's using it.
Oh, dependence. That's cool.
Yeah. It shows you some pretty cool things. These package manager stuff.
Hashing. Yeah, all this stuff. Elliptic. I saw an elliptic curve there.
Yeah, I saw that was. That was the first one.
Oh, I think there was one below as well. Something else. But, oh yeah, all the other ones are so few downloads.
Right.
Curve flow. Anyway, yeah, the ones that matter the most are the two ones on the top.
Oh, cool. Elliptic curve package. And then I'm curious if any of these use.
Dependence of the dependent.
Right.
Ah, that's a different curve there, right? CCP 256R1.
Yeah, I don't know. I wonder what the R is.
I was looking into this. There are K curves and R curves, but I don't remember the difference.
Yeah, I don't know. Huh. Anyway, okay, irrelevant. Let's use this crypto bigint. And hope it works. So there, you copy this here and then throw it into your cargo.toml file, and now it's available. That's it. It's the magic. So I guess we need to figure out what maybe not struct type definitions. So an unsigned 256 is what we're going to be using.
U256. Oh, cool. It's just adding more bits. Should it be auto-completing?
I thought so. Well, it's still fetching metadata, so we'll give it a second. We can also do like a cargo build. Well, that's not going to build because it's okay. Yeah, so it's blocking, waiting on the Rust analyzer to finish fetching all the metadata and everything. So we'll give that a second.
It's kind of like downloading, like kind of pip installing.
Yeah, it's downloading everything in the background to make sure we have everything. But yeah, now we can represent 256-bit numbers, or at least that's what this thing says we're supposed to be able to do. I'm kind of curious how they do it, but not that curious to go and actually look at it right now. There we go. U256. Yeah. Is this integer? Wait, that's wrong. It's not that type anymore. All right, so it should. It still doesn't like. Still doesn't like that.
It's saying I32 right in the pop-up.
Yeah,
So,
I thought it was weird. Let's. All right. Let's just. Let's build this thing. And if we can build it, it should, maybe it'll refresh some stuff. It's still talking about how the integer literal is too large. Okay, so we might not be, all right. We might not be using it. We didn't read how to use it. Okay, so here it is. All right, so yeah, you have to use from hex. So, I wonder if it's big endian or not. Interesting. So, let's see all these different functions, U256 and from. I want that from. So I don't know if this is from words. That's weird. I think we're going to use, we need to determine this. Well, I guess we'll find out, I guess, if it's big endian or little endian, if it doesn't work. I want to remember, I vaguely remember that being mentioned somewhere in the book about the endianness of some of these values. And we might have to do a search for that in the book to figure that out. But this is working for right now, so that's cool. And then, oops. All right, so what's the next value we're designing? P. So I think P is going to break too without...
Oh yeah. It's basically 256.
Right.
The little
So...
swept from the top.
We should look up how to... All right. It does modular arithmetic. That's cool. We need to find a... I mean, I guess that is... It says addition... So it doesn't do... I was looking for like... Yeah, exponentiation. We might just have to find it somewhere. Doesn't look like it does. So... Exponent... Let's see what sort of from it has. And from words, I don't know what that one means. Well, all right, let's see how we can get to that. We know it's going to be a U256. And then, what is it, 2 to the something power?
Power of 256, yeah. Yeah, that's what it was. So it's to the power of then. Ah, you have that. Yeah, this is int. So
I think so. Yeah, hold on. I can never remember which one Rust uses. Okay, it is POW.
It is POW. Okay.
Yeah. .pow. Oh, and this will so this is is going to be an excuse me. We can... So what I'm thinking is we do the U256 and then we do like addition sort of things. If that makes sense. Let me try to think of the best way to do that. Trait bound. I think there's a way to like inline the types next to the numbers. So let me look that up real quick. Like I think in some languages like as something else. But do you just put it afterwards? Like an underscore? U64? Okay, yes. So, all right. Yeah, so you can just do, I think it's just you do an underscore to tell it like this is what that number is, sort of thing. See. Yeah, I'm pretty sure that works. So, But what I think what I think we'll do is we'll do a U256 from U64, right? And we can do addition with these. And so what's the next? I wonder what the next.
Minus 2 to the power of 32. So yeah, negative addition.
So it's minus, and then you said 2 to the what?
To the power of 32.
To the power of 32. All right, cool. And then what's there's a final one, right?
Minus 977.
Just 977.
Yeah, just because.
Okay, cool. And we've got some errors here. So what's this thing complaining about? Cannot subtract. Okay, so there's probably some arithmetic operation to be done. So I wonder if we... Yeah, it's going to be too big. Yeah, so let's look up how to use that. Back to the usage page. I thought it had... Yeah. Oh, it's got wrapping arithmetic. But that's still checked arithmetic. What is oh, okay. All right, so I think the checked is, yeah, it gives you an option. And I believe the checked is like it will provide intentionally checked arithmetic. It will check to make sure that it's good. As opposed to wrapping will like go like wrap around. So if you get to the max number, it goes back to 0 sort of thing. Does that make sense?
Mm-hmm.
Yeah. Max plus 1 wraps back around to 0. But checked... What is this? Check. So I think we want checked arithmetic here, if I'm not mistaken. But we're going to have to grab out the result of it, but that's okay. So I think we have to give it these types. We call these checked functions. Like this. It's getting all kind of... And we got to qualify this. Or import it, rather. Oh, that's a Saga word wrap so we can see what we're working with here. All right, cool. So we have this checked value. We have this checked value. And we have this checked value. And this is going to be another 256 from, we'll just say U64. Oh, and I think this is not the right type now for P. Yeah, P is now a checked uint. So what does that mean? So checked. Okay, checked. Has some trait implementations. It is CT option. What is a CT option? An optional value, but it's intended to use in constant time. Oh. The value can also be changed unwrapped, but this will panic if it's null. Okay, so it has something to do with constant time. And that's something that I don't quite understand what that is or what that means. I'm assuming constant time has something to do with like the big O complexity of how this was written, but I'm not 100%. But let's see what P gives us. Okay, so it's a tuple of some sort. Okay, and then we can check. Is some, is none. I mean, we're just going to unwrap this, I guess. We'll P math. We'll call it P math because then we'll assign actual P to be the value. If that makes sense. But it is not. We want this to be U256. So how does that work? Does that work? Yeah. Yes, maybe. It's not throwing any errors right now. Let's try to build it and see what's yeah, okay, so it built just fine. So it seems to like that. Well, now we define P. What's next? N. Or no, we don't define N. We need to do assert equals. And with the GY. Oh, you know what we didn't do? We need... Oh, man, okay. We might have a bigger refactor on our hands. Because GX is a field element, right?
Yes, it is. Or you should, yeah.
Well, we don't. Okay, so we don't need a field element yet. We can just verify this basic equation.
Applying the modulo without creating the field element.
Right. So let's. Okay, so there might be. Oh, we didn't see an exponentiation.
For these 256 numbers, like.
Right. Well, okay, so it's simple enough because it's just times 2 or to the second and the third. So we can
Times itself, yeah.
Yeah, we should be able to do GY times GY. And that's part of it. And then the other but it's modded by P. I don't know if that's going to work. I don't think it's going to like that. Oh, I guess it does. Okay. And GX times GX times gx plus 7. And then mod that by p. Okay, yeah, so there are things here it doesn't like. Cannot multiply this. So I think we need to find... So there's a multiplication for arithmetic. Oh, we need to do another checked thing. Oh, okay, so modular arithmetic. We wrote all that modular arithmetic code, but maybe we just use this now. Man, look at this. Makes it so much easier. Are you reading this?
I am. I'm not making sense of it yet.
So this is essentially, creating a modulus, right? So if our modulus is 3 or whatever, in this case, modulus is going to be p, the prime number. And so 1 plus 1 mod 3. So it's 1, the value of 1, add mod, and you give it what to add it to, and then the modulus. And then it gives you the result back. So I think, if I'm not mistaken, we could do, yeah. What is molmod special? Interesting. I don't know what molmod special is, but let's look it up. So molmod special. So there's a molmod. What is molmod special though? For special modulus. See, this is where it's like getting into like, what is special modulus? Is that like another? Is that another thing?
What's special about it?
I don't know. That's what I'm saying. I think this is some other. This function. So this function implements algorithm 14.47 from Handbook of Applied Cryptography. So a little bit above my pay grade. Let's figure out, how do we get this molmod to work? Or why is that not a function? And we just mod by p. There's this associated function with a similar name. No, it's not submod. So gy is... Molmod. I'm trying to think about... These are all U256.
And it's saying no method named molmod found for struct uint.
Right.
That's not related to why it's not working, right? You shouldn't be saying for struct U256 there.
Yeah, I don't... It should... Yeah, it should... I thought it should, but it's... The U256, it's like a weird... This is a type, but it's actually a representative for this uint thing. That's something I need to, I guess, learn a bit more on Rust. Interesting. Let's... Let's add. I mean, And it doesn't give us a usage example of the mul mod. So let's find. Let's look at some of these other docs pages. To see if this will give us something. Implementers. There's no implementers of this. So I wonder if if they don't have this implemented. Is that what, like maybe there's an outstanding issue that they haven't implemented it? Yeah, okay.
There it is.
Yep, there it is. So it's talking about they have not implemented mulmod, so standing desk. Nice. Man, this is like they're talking about some high level math type stuff that I don't understand at all.
Yeah.
So, I mean, maybe we just don't use this crate then, and we look at some of those other crates. So let's look at what was that other crate? There was another.
I don't remember now.
There's another Rust big int crate. I think it was num big int, if I'm not mistaken.
Oh, there it is. Yeah, we kind of fell for the cryptography term in there.
We should have stayed away from crypto. we should know better.
Never learn our lessons, man.
Right. Is this the one though that we were looking at before? I don't know if it was. Num big int, yeah. And this one has more downloads too, by like an order of magnitude. So we're dumb. We should have stayed away from shitcoins.
Yeah. That's the lesson, man. That's lesson number 1.
Right. I feel so ashamed right now. We're ending the stream. We're deleting it, and we're going into degenerate trading.
100x.
Max bidding.
Leverage. Yeah.
Max bidding. Do you watch Shake Roberto? Have you
I do, yeah. He's funny as hell.
Yeah. Okay.
He does dabble a little too much in shitcoins, though.
Yeah.
He's got that friend, the dev.
Mm-hmm. Yeah.
They keep trying to play it tough, like, Bitcoin only, but then you follow a couple links away and they're selling shitcoins already.
Right. So it looks like we can just use this big int type. So let's refactor this a little bit.
Mm-hmm.
Or big U int. And maybe we can use the hex literals. No. So how do we do it? too big int. Can we just call too big int on it? Yeah. Hey, look at that. That didn't work.
Ah, it's like
It's too
a big wind.
big wind. Yeah. Okay, so this big wind. I wonder if it is big enough. Like maybe. I would think so. So we need to use, I think, big wind new is what it looks like. No, that still doesn't. It still doesn't like it. From probably hex is probably what it's gonna be. From bytes? No, we don't want bytes. Or is it parse? Is there a parse method? I saw a parse method in there. Parse bytes.
And not parse.
It's not.
X. That's a thing.
Yeah, it's not digit. Okay, so new, you give it a vec of unsigned 32-bit integers. How does the base 2 to the 32nd digits are ordered least significant digit first?
So that's a little endian.
I think, yeah. All right, let's ask ChatGPT-3. We'll see if this will. Cool, we get a connection. Connection. All right. I use big uint in Rust to define this number. This, well, it should know that's hexadecimal. Let's see if ChatGPT-3 is it's off to a good start. This seems promising. From string radix. Oh.
Radix.
Oh. And then you define the base. Okay, so I guess that's another from string radix. So is radix another word for base, it sounds like?
The base in mathematical numeral systems.
Okay. So yeah,
like radical, like root.
Well, today I learned what radix is, and it just means base. Okay, so that makes sense then. So you say it's from a string, and you tell it you want to use a radix, but instead of annotating the string with a 0x to say that's hex, it's base 16, right? And this is going to complain. Yeah, so it's a result sort of thing. So we'll just unwrap this because it should just work. Sort of. Yep. Okay. Or we're going to trust that it works. Or if it doesn't work, then we want it to. We want our test to panic, right? We're just writing a test. It looks like all we're going to do is write this test today, but it's good because we're learning about making really big numbers in Rust, which you need. Why do you need big numbers for Bitcoin?
Because it's gonna go to the moon. Big number, man.
Yeah.
Bitcoin to the moon.
Oh, yeah.
That's why.
Yeah, you're right. No, do you remember the mathematical reason why we want to use really, really big numbers? Do you remember what it calls out in the book? It's
I guess because you need to make it large enough so your computers can't brute force the answers.
Do you remember what that's called?
The discrete log.
Yes, discrete log problem. Yeah, I think side tangent. I'm pretty sure there's a discrete blog.
Discrete blog.
I thought Matt Odell has something.
I saw something on GitHub there.
Was there something on GitHub back here?
Yeah, if you go back one, I think it was like the fourth result or so.
Oh yeah, here it is. Discrete blog. Okay, so maybe it wasn't Odell. But this is interesting. I thought it was. I thought there was. I thought he had something else that was some sort of blog. Matt Odell. I guess not. Okay, yeah, so it's... Here it is, yeah, the discrete log.
Ah, there you go.
Discretelog.com. There you go. Bitcoin is...
So it's the other word, discrete, as opposed to discrete.
Oh,
or
is it
the same word?
Is it two different words?
Doesn't have the double E? I don't know.
Well, there's a discrete versus discrete on Grammarly, so...
Exactly, yeah.
They're homonyms. Anyway, we're tangenting away.
Homophones. They probably sound
Yeah.
the same.
Interesting. Well, now I gotta go back and read this. Yeah, it's pretty recent. How Bitcoin is not a Ponzi scheme.
Yeah. Okay, I want to check this out.
But anyway, thank you, Matt Odell, for everything that you do. But now we can create our big wins, big wins, and we can then.
Oh, and you can see that in this case they have the big wind type.
Right.
As
yeah.
opposed to when we were using the cryptography library or crate.
Yeah, this one is. I like this library better. There's a reason why it has 48 million downloads, and not just 7 million. The 7 million is probably for 7 million different shitcoins, and that's where we went wrong.
Exactly.
So
we learned.
Let's see if we can define P straight up then as a big wint. And I wonder, okay, so excuse me. I'm wondering how we defined the big wint using the multiplication. I wonder if there's like a from, let's see, from bytes, no. From radix, no. Turns an iterator, interesting. So there is a POW function, so that's kind of cool. So I think we can do then, if we do big wint from U. We can do from a U8 because it's just the number 2, right? And then dot. Oh, we have to unwrap it. I was wondering, I was like, there's no POW function. There's no POW function. But there is a POW function. There's even a mod POW function. That's dope. So 256. And we are modding. No, we're not modding for this. We are defining the prime number. I'm sorry. My bad. I was getting too excited. POW. So, okay, so from U8, because we're doing 2, and then 256. Let's just make sure that works. It's not complaining. It just wants a semicolon. Nice. Okay, cool. And then I think we can do a minus from a big wint. And we can do again from a U8. And then 2, unwrap this bad boy, and then POW it to, what was this one?
32.
32?
Yes.
And then plus another big wint from...
minus. We're going to do 977.
Oh, you're right. I'm sorry. Yep. Good catch. From you, we'll just do a 32. 977.
Mm-hmm.
And unwrap that bad boy too, because we know that's going to be good. Cool. Nice. Okay.
That's our let P.
Yeah, that's
the prime.
That's our prime.
That's the prime. That's right.
So now
is it rustic to do constants with a capital P?
if we were defining a constant, yeah, but because we're defining like variables, because we had a constant in our where do we have it? I think we had a constant in our point class. Yeah. So it's.
Then you would also use a capital letter.
Right. Yeah.
Okay.
Excuse me. And Rust has like, if we did something different too, I think it has this clippy thing. Yeah, constant prime should have upper snake case. So that's what it wants, is upper snake case.
Nice.
Yep. And you can do, I think it's cargo clippy, will like analyze your Rust code and tell you like where you're dumb. Not where you're dumb, but like where you could do some small improvements. So like we never use multiply by, we never use this, so it like tells you like, hey, you never use this, you might want to get rid of it.
And clippy is the word character.
What's that?
Right, the Microsoft Word character.
Clippy, yeah. The paperclip that used to like yell at you. But yeah,
annoying.
Things like this. So like manual implementation of an assign operation, where it just says like, hey, you can make this code cleaner. So clippy is like a huge, again, another sort of like assign operation.
You can do a assign operation with a modulo. That's interesting.
Yeah, I guess so. In Clippy might not be aware that we haven't implemented the assign operation right? So like there also might be that. Like I don't know if it analyzes it that deeply. But we could just check it. But yeah, Clippy helps you write better Rest code, basically.
Thank you, Clippy.
Better Rust code. But where were we? We were
our tests here.
Our tests, yes. So,
Assertions.
and this is GY pow to the second. And it's going to be equal to GX pow to the third. Why is this pow? What is that? It is a U32. It's a big wind. The trait bound big wind path is not satisfied. The following other types implement trait. What? It's not for big wind. Oh, is it? I think we have to tell it it's a U32? Okay, yes.
Interesting.
So yeah, it didn't like the type. So it doesn't have a version where you feed it in a signed integer. It only wants an unsigned integer.
All right. And then modular.
Wow. Yeah. But I think.
No modular P. Oh yes, I think so.
Yeah, but P. What is wrong with P? Oh, consider giving P an explicit type. All right, yeah, let's do that. So these are. Oh, okay.
Here.
Yep. Yep.
32.
Yeah, that's probably fine.
Uh-huh. Just casted my first integer as an unsigned.
Yeah.
Look at me, man.
Okay, so this is an interesting one. So this gets into one of our first encounters with the borrow checker, or the ownership, and it says, use of the moved value P. Now the reason P is moved is because we've consumed it in the code prior to. So this is yelling at us because so big wint doesn't have a copy trait, and it tells us where the move happens. So we have this P here, but it's used. Oh, bring that back up. It's moved on line 21, which is right here, right? So it's defined here, and then it's moved here. I think, if I'm not mistaken, we can just borrow, and then everything's happy. And so what this means is if we put this little ampersand in front of it, it's like borrowing the reference to it. It's saying like, hey, I'm going to use this. I'm borrowing this value, but I'm going to give it back when I'm done. Whereas without the ampersand sign, this is consuming that P. And so when this operation is done, this modulo operation, when that's done, P goes out of scope after it's used. Or it's not that it goes out of scope. I mean, I think it is that it's not that it goes out of scope. It's being consumed in the function, in the modulus, in the modulo function.
Is it like memory allocation? So then it frees up the memory.
Yes, yeah. It has to do that because this function becomes the owner. Yeah, so that's what it does go out of scope because this function becomes the owner of P when the function is done running. P then goes out of scope and is gone. But it complains about being moved. And it also talks about the copy trait, where the copy trait allows you to do like a dot. Well, I guess you can clone, but copy allows you to sort of like implicitly like clone things without worrying about it. But it seems to just work also with the ampersand by borrowing it.
Yes.
And that way it's still available for use later on.
Maybe if you were to use P again, you would have to keep borrowing it.
You could. Yeah.
This one as well.
Well, you can also, I think you can do
keep it alive.
So I'm pretty sure this will work too. So you can do a P clone. It's just, I think what it's saying is it doesn't have. Let's look up the copy trait. I believe the copy trait is just it will automatically clone it for you, and I think because what I'm guessing. Types whose values can be duplicated by copying bits. And I'm guessing they don't implement the copy trait for these big wins because it's memory intensive, right? Like these are big numbers that are going to be consuming a lot of resources type of thing. I could be wrong with that, though. I could definitely be wrong. But, cloning it or borrowing it, right? And it depends on kind of like how you want to do it. You don't necessarily want to clone everything because that's just, you're wasting memory at that point. If a borrow were suffice. And there's some other like ways of doing it. But do you want to see if this thing runs? Do you think it's going to pass?
Let's take a look.
I can't look. That's building. Passed.
Oh wow, amazing.
Okay, so we've got a lot. Oh, excuse me. We've got a library now to deal with these big numbers. Cool. What's next? Because I think there's another test, right? We can verify in Python whether the generator point G has the order of n.
Yeah, let's do that.
Yeah. So
it's gonna just one step further.
Right.
Calculated B.
Generator point order verification. So we can copy all of this because we're going to reuse that. And then we need to... Okay, so this is... All right, so we're going to have to do an N. And then we're going to have to refactor this. So we might not be able to finish this tonight, depending on how long our refactor takes. Which I think is actually going to take a while, because we're going to have to convert everything in field element to work with big wints. Do you see why?
No, not really.
All right, hold on. Let me finish type. So I'm pretty sure we have to do it because we're going to have to define field elements using these big winds, these points.
Oh.
Right, and specifically the prime number, right? The prime value we're going to have to use. So we're going to have to update our field element that instead of a U64, it's going to have to accept a big wind, which is going to be it's going to be a big refactor.
All the arithmetic, all the stuff basically.
Right. And I mean, I don't think it's going to be complicated. I think it's just going to be a little bit tedious, right? Because it seems like this library has all of the functions that we need. And maybe it won't. Maybe it won't. You know, we can just, there's a really quick and easy way to convert it. And I say quick and easy as in like you do a control F, you find a U64, and you place it with a big wind.
But then there's the unwrap at the end as well, right? It might be.
That's true. Yeah, we'll address those as we go. We can update these big winds. All right, so I updated a few of these. Just the types, I guess, of just the types. And then of course there's a bunch of errors now. So let's import big wind. So we can't implement copy type now because this big wind type does not implement copy. So we cannot auto implement copy. We can't implement clone, so that's cool. So we keep that. These functions sort of work still. Do all these work? I'm not seeing any. No way.
That's it? I'm gonna try it.
Yeah, I'm skeptical as hell, but let's see if it builds. Okay, yeah, it didn't build. Oh, but it didn't build because point now cannot implement the copy trait. Okay, that's fine. Oh, look at there's this. All right, here's a problem tab. So cannot subtract it I32 from a big wind. All right, yeah. So this is Ooh. Excuse me. I'm sorry. Yeah, so I think this is gonna be a little bit bigger of a refactor. Do you want to try to crush through this tonight, or we can? We're at an hour and 20. Okay.
Yeah. Because every operation like that -1 that you have there, that would need to be refactored to big event.
Well, this one I would just get rid of, like. I would just get rid of that.
No, because this is just the string formatting.
Right. Yeah. That one's an easy one to sort of get around. This one I think is probably easy. I think there's a 0. No, maybe. Like I think there's a 0 number in the like crate. And we can find it maybe. Yeah, big int 0. Or big wint 0. Right. So that one's an easy one. Sort of. Mismatched types. Yeah, so these are all going to be... Okay, yeah, we can... I might refactor this in my free time, just depending on what sort of free time I have. Because I don't think it's going to be... Yeah, we'll see. We'll see what my free time does. Maybe we'll refactor next week, or maybe I'll get around to doing this. But
Sounds good, yeah.
Let's commit some code. Let's see. So first, cargo.toml. Use num big int don't shitcoin. Bitcoin only. Cool. Got it.
The red flags were there, right?
They were there and we ignored them. Everybody gets it. You know, when you first get into it, you're like, I just need a big integer for massive prime numbers. And you see the word crypto and you just cry a little bit inside. It's the red flag, yeah. And then we wrote a test specifically use to validate at least one part of the Bitcoin curve. SECP 256K1. So let's do that. SECP 256K1. We'll commit that as well, and then we started to do a brief refactor. Begin refactor to use big wint for field elements. And that was, yeah, that was that. Okay. That's good, and I'll push those up, and yeah, interesting. I wonder how, now I'm curious, like, how Bitcoin Core does it. You know what I mean?
Because C++ is similar in this sense.
Well, just like, I mean, I guess it's similar in a sense. But I remember
just accept the big numbers, the big ints natively. Maybe it also has this limitation.
Yeah, but it says 2 to the 56 can be stored in 32 bytes. Oh, 32 bytes, not bits. It's not, okay. All right, I'm dumb. We should go now.
But yeah, exactly. Yeah, 256 bits, 32 bytes.
Is it? Because it's what, 8 bits in a byte, right?
Mm-hmm.
Okay, that makes sense. What? Why is that?
256.
Okay. Yep. Makes sense. Cool, man.
There's probably a big ant library for C++.
I mean, you want to go look at Bitcoin Core and see if we can't
let's
deduce this. I mean, might be a good last little thing that we try. So,
which will maybe not too soon, but in the future be moved to Nostr.
Maybe.
Right?
Maybe, yeah, I don't
At
know.
least the meta conversations, the meta communication.
I don't know who would do that. Crypto. I don't think it's under crypto. We should do a search for, I'm trying to think of even like what to search.
Good question. Do S256 field.
SCCP 256K1.
Ah,
There's a folder for it.
yeah.
Of course, it has its own folder. It's an optimized C library. Interesting. No runtime heap allocation. So they're doing some crazy stuff then. I wonder if BigWint has heap allocation. Do you understand the heap versus the stack?
Not really.
So heap is sort of like your memory outside of like your CPU, like RAM and stuff. Stack is, and that might not be exactly what it is, but stack is like a faster access. So you store like big things on the heap, and then you store a pointer on the stack to the heap on like where that data is, sort of thing. Right? So if you have a pointer, it has the stack, it'll look at it and say, oh, this is where the data is, and it has to go get it from the heap. But if you're storing the data directly on the stack, then it's very, very fast.
Which seems that's what this library is doing. No heap, all stack.
Right, yeah. And I don't know.
Oh, yeah, using 4 64-bit limbs. Scalar operations.
Is that 464 bits? Is that 256 then? Right? I'm bad at math off the cuff like that.
Yeah.
Okay. Without data dependent.
Arithmetic modulo the curves order.
Or 8
seems
32-bit limbs. Huh. Scalar operations. I wonder. Oh, look. Yeah, see, this is all. I don't understand.
What are these H files?
They're header files.
Header.
And I don't know what they're used for. This is C, right? I don't. It's like a weird, like you include them, so I guess it's like packages somewhat, but I don't know. I never learned C. It looks complicated.
Well, you have your structs there.
Yeah. Yeah, so they define the type. Interesting. What we're looking. Oh yeah, we were trying to figure out how they were storing their big integers. But anyway, this is all Greek to me.
Size T.
Where do you see that at?
Let's scroll up a little bit. There you go.
Where? Oh, size T. I don't know what that means.
Yeah, me neither.
Maybe one day I'll go learn C, but I feel like if I'm learning Rust, I'll be good. That was my whole thing, was learn Rust to learn a systems language, which C is a systems language. But anyway, Plevlira, thanks for hanging out again, man.
Of course, man. My pleasure.
I hope it's not too boring. I felt like this one was a lot of just like me talking about.
Yeah, it was a little off my league, to be honest. But I'm learning so much.
Have you done these exercises in Python?
I've done them. Yeah, I haven't when you play around with the exercises, you change there to see, get a good hang of it. I haven't done much of that, but I played around with them.
Okay, cool.
So well, got some company in the back there.
I do. I see a
Wants
little.
to leave.
Never. Little fur baby.
Yeah.
Awesome.
That's Tutu.
Tutu?
Yeah, from Tulip. Tulip is her name.
Oh,
Tutu is her
okay.
nickname.
Okay. I like it. I like it.
She's cool. Yeah.
Well, with that, we're gonna sign off the stream. Do you have any final closing comments, or does Tutu have any
No,
final
that's
closing
it.
comments?
Yeah, just Tutu's chill. She just wants to leave the room. As you can see, she's like waiting patiently by the door.
Well, she's waiting
So
very
yeah, she also
patiently.
doesn't have anything to say.
Perfect. Well,
Oh
let's
yeah, not patient.
let's stop the stream so you can go let her out. But thanks anybody that's been
Yeah.
tuning in, and thanks anybody that's watching in the future. Bye.